Okay, now meeting has recorded now. So we'll see the syllabus first, and then we'll discuss one by one there. Okay, now this is about a sharing screen. So we have uh, this micro communication. We'll see that there are three theory, and we have three credits there. Now a textbooks we have mentioned here: micro device and circuits. That is Leo, and one more is about micro engineering. That is a Mitra. Along with that, references books we have this Posner and Kennedy, that communication systems and all. Now, uh, there are these are the only textbook and reference books written in the content, but there are lot of textbook and reference books are available there. So I will share you all those books to you, as well as I will share you the some PPTs to all of you for all these units that we have prepared last year. Same PPT I will provide it to you. You can go ahead, go through those PPTs, as well as I will provide you a, a, uh, I will provide you the details about whatever the thing we are learning in this particular period here. Okay, in this particular syllabus. Now, this is about when we are learning this particular subject, we should know that what are the course objective and a course loading outcome. Objective means what we are learning, what we are getting from this particular course, and what you are learning there. So that's why a learning outcome, after completion of this particular course, you are getting this particular thing, and what you are looking for, that is nothing but a course objective. Okay, in a whole syllabus, what you are looking for is about nothing but the objective, your aim, what you are what you are studying in this particular subject, and a learning outcome means what you are getting from this particular subject. So that is about your course objective and a course learning outcomes here. Next, about we need to see that where we are mapping this particular course outcome and course objective and course learning outcome. They are about a mapping, so not to be used here. Okay, so we go ahead here. So then for all this, okay, all these particular syllabus, we have a standard format of 46 model and 3 model before MSc and 3 model after MSc. So we can go ahead with this particular model one. Okay, and we'll within it is mentioned that it is 6 hours it takes. So we can go ahead according to the hours. Even if not sufficient, we will continue. Okay, so till which wherever how long we are getting the time and all, according to that we'll continue the lectures there. Okay, also I will help you to provide you the some nptel videos, so that you can learn this micro communication easily. So from my point of view, we can go ahead with this one by one model each. Okay, and then there are some theoretical portion we'll cover here, and once we are getting some particular tool regarding that numericals and all, at that time we can go ahead with that numerical. Otherwise, we have a camera, we can focus that camera on a board, and we'll solve some numerical because according to those particular models there. So model one, okay, if you see that it is basic one. Okay, micro fundamentals and electromagnetic field theory. Just we are learning here the micro, what are the micro band, what is the micro regions and all. So it is not related to anything, okay, that people are thinking about it is related to the electromagnetic engineering. Okay, we are learning electromagnetic engineering here only, that is a part of wave. Okay, because wave is propagating through the waveguide, and that is nothing but a transmission line. So that's why we are looking for that electromagnetic plane wave here. So this particular model, it is just a fundamentals related to your whatever the field theory you people have learned in third year. Okay, that is a part. There is no relation of that whole subject related to this. We are interested only the wave, how that wave is propagating through a waveguide there. So that is a model one, micro fundamental and electromagnetic field theory. And just we learn here in a micro, what are the region, what are the micro regions, what are its band, okay, what are the micro devices. Okay, each and everything that we are relating to the micro, and then how wave is generated there, that we will learn, and that is a part of your model one. Next, a model 2, we can go ahead with a transmission line components, that is waveguide and its component there, and how your signal propagating through the wave. So that's why we learn here the different modes, TE modes and ATM modes. And then we have all these parameters or components of these waveguides, that is junction, T's, okay, whatever the coupler, circulator, alternator, phase shifters, all those components we are learning. Along with that, we'll see that a S matrix of all those particular model here. Now we will see that in model 3, that is a tube. There are two types of tube, actually O type tube and M type tube. Now that is O type tube means what, a linear tube. M type tube means what, a cross tube is there. So in a linear tube means what, your electric field vector and magnetic field vectors are in the same axis or linear there. So that's why you can say that it is a linear tube or O type tube. In M type tube or a cross type tubes, in that electric field component and magnetic field components are perpendicular. So that's why these are called as a cross tubes there. So we learn those tubes, okay, that is related to your field components and all. Okay, so now we can we learn that in model 3 there regarding the tubes and all. Then we have a micro solid state devices, model 4, model 5, micro measurement, model 6, that is micro strip lines and all. And then what are the things you are learning? Okay, what are the measurable things you are getting from those particular models? So that's why we have a model wise measurable student learning outcomes here. We'll go ahead one by one this particular model. Okay, we'll see the syllabus details in each and every model there, and then we can have discussion about this particular syllabus there. Okay, something is here waiting in the lobby. Okay, let it be. I don't know what to do now. How they have to allowed. Okay, okay. I don't know that participants there. Admit Pranav tag. Okay, let it be. Yes, admitted here. Okay, now these are about your theory. Okay, so then that is about a lab. In a lab we have in a microcommunication lab. Okay, everything we are saying that textbooks, theory, everything is same. We are just changing this particular mapping and all. Okay, these are about the lab activities for week 1, week 2, week 3, week 4. Okay, but here we are learning this particular equipment, micro components, characteristics of a gun diode there, a klystron, then a characteristic of a T is here. Okay, then we have okay, port characteristics there. So each and every practical, I will prepare one video so that you people are able to watch those videos, and we according that way we can complete our lab, because there is no virtual lab for those particular practical list of the practicals we are looking for. So that's why we have an alternative here. So we have to prepare a PPT there. Okay, that video for those practicals. I will share you all those videos along with the readings in a lab manual. You just keep that lab manual with you. That word copy I will send you. Then all of you have to write down that conclusion for each and every experiment, and then submit that lab manual to me. Okay, that is about our procedure. We just supposed to be consider that there will be a lockdown till December. Okay, that is we supposed to be consider. Okay, so that's why students will not come in a campus. So according to that, we'll go ahead that how that syllabus is to be completed there. So that is about your theory and a lab. So we start here with a model 1, and in that model 1 we will learn here what are the components for this particular microwave communication there. Okay, that is about your model 1. We learn about the fundamentals of a microwave. What do you mean by that microwave there? Why we are learning microwave? Okay, what do you mean by micro? Micro means what? A small. Okay, that is about a small wave. So we learn here a model 1, and then we learn that one by one each topic. So now we go ahead with the another content sharing here. So that is about our PPT. PPTs are here. Okay, where is the PPTs are here? Okay, so we can go ahead with the PPT now. So share the PPT. Okay, okay. Now PPTs are shared. Yes, are you able to see the PPT? Please write down some message. Hello. Okay, okay. Thank you, Karan. Thank you. Now these are about PPTs. Already this PPT with me. I will provide all this PPT of all model to you, and then you can continue. Okay. Now these are about a PPT here. We can go ahead. Okay. Now we can have expand panel to show video. Okay. Let it be. So now this one is about your model one. So model one, we have a micro fundamentals and electromagnetic field theory here. That same syllabus we have just discussed earlier. So we have a micro regions and band designations there, micro device applications of micros, then interaction between electrons and the fields, and then we will learn that electron motion, electric, magnetic, and electromagnetic field, electromagnetic plane wave. Okay, these are about your model one content. Okay, then we have this syllabus there. Okay, now we start here with a micro engineering. Now, as I told you earlier, this micro is nothing but what a small wave. Small wave, so that's why we need to learn about the what are the micro frequency bands and all. So for those micro frequency bands, you should know that in which region that micro frequency is present. So that's why we basically see first what are the positions of a micro frequency signal in this particular band of a radio, that is about a radio spectrum there. So here these are about this one is a entire radio spectrum, and you can see that a 0 to 30 kilohertz, we say that very low frequency, 30 to 300 kilohertz low frequency, then medium frequency, then high frequency, very high frequency, then ultra high frequency, super high frequency. Okay, so now these are about the uh, admit. Okay, now these are about the frequency band there. Then super high frequency, extreme high frequency, okay, sub millimeter frequency. Now a micro region is belongs to what a zero point 0.3 gigahertz. Okay, that is from the zero point 0.3 gigahertz to that's about the 3000 gigahertz. This is about in this particular entire radio spectrum. A micro frequency belongs to what a zero point 0.3 gigahertz means what a 300 megahertz to 3000 gigahertz. Okay, so now you people are uh, working on this today. You people are using a mobile phone and it has a 4G, and you people might have seen that that standard 2.4 gigahertz is used for Wi-Fi. Now new standard is about another Wi-Fi band is about the 5 gigahertz people have specified. So most of the mobile phone nowadays they are available two Wi-Fi band. One is about 2.4 and another is about the 5 gigahertz. Okay, then the technology changes according to that. That other things will changes. So right now 5G 5G will come. So that band for this particular 5G is about the 4 gigahertz to 6 gigahertz there. So let it be. That is about a micro frequencies. All about we need to learn. But nowadays people are switching their opportunities in IT industries. Okay, but if you people are looking in a communication there are a lot of jobs available in a communication industries, but there is a lack of what talent or lack of people they are looking for these particular uh, companies there. Okay, so that's the problem people are facing. Okay, so if you wanted if you go for the core job, I am just saying that you can go with a VLS and you can go with a microwave. Don't go for the IT industries and all. So IT means what? There is nothing but a software. But in again a communication, we people are learning a software that is a communication related software. Okay. So that is about all the tools are available there. So you can have a specific thing you can learn from this particular uh, communication engineering there. So now this band you just remember always. Okay, microwave, that is micro, word micro is nothing but a small, and that is about the wave. So now if you say that here, that wave is a small, wave is what, here is it is a wavelength. Wavelength is about what, a 1 meter to 0.1 meter. Then what we can say, that 10 centimeter to 1 centimeter. Now if you see here, that wavelength is a small, so that's why, because of a small wavelength, so people are saying it is a microwave. Okay, that is about a small wave. Now this micro frequencies, okay, we have specified that where these micro frequencies to be used. Generally, you people know that, you people have learned that uh, this earlier, that in a communication you people have learned that analog amplitude modulation, frequency modulations. Okay, I think PCM, all those communication, I think that antennas related some topics you people have learned. Now in those particular thing, you people have you people were use that cable, okay, that wire, and that wire is nothing but what, a coaxial cable. But in this microwave, what happened, this frequency is large. Okay, your frequency is too large. Because of a large frequency, we could not use a transmission line, because at a high frequency the transmission line will act as an antenna. Your, okay, so because of that, it act as an antenna, your signal will what radiate in space. Okay, so that's why people are design a transmission line, and the transmission line is called as a waveguide here. So here, any micro frequencies, we will use a waveguide as a transmission line or as a media of a micro signal propagation. So that's why we say that we have an entire radio spectrum, and we say that in that entire radio spectrum, it is about a microwave. But again, if you go ahead above 3000 gigahertz, some band is there, okay, some frequency is there, and again it is very very small, and that band is called as a, okay, that band is called as a infrared band, or you can say that a visible light band, or X-ray, or a gamma rays. All those rays, that is again below that. Okay, so this one is about your micro frequencies here. So basic electromagnetic spectrum is classified into what? Whatever the radio spectrum that is utilized, whatever the micro frequency band or a millimeter waves, we can say that UHF to AHF here. And again below that we have a visible light, infrared light, X-ray, and a gamma ray. That is again that wavelength is a very very small there. Okay, that is in, it comes in the form of a infrared light, or in the form of a ultraviolet light and all. Okay, so that is about, or you can say that a X-rays or gamma rays, that will come again. Okay, so you just see here in this particular micro frequency band. So we say that it is about a zero point 0.3 gigahertz to 300 gigahertz. But specification, if you go ahead with the specification wise, so people have not defined a standard clearly. Okay, IEEE has not defined the micro frequency range clearly there. So that's why that certain band designations they are providing. So right now I'm saying that a zero point 0.3 to 3 gigahertz. Okay, that is about too large range, and in that particular case, a bandwidth will be too large. So according to that, so IEEE have designed some band designation, and that band designation used for uh, what different purpose. Suppose I am saying that C band, okay, L band, okay, like us. So we have those particular band there. Okay, so IEEE micro frequency band, and they have specified this particular band there. Now, if you see that entire frequency band, that is about the zero point 0.3 gigahertz to 300 gigahertz. Okay, but these are the different range, and in that particular different frequency range, they are having a specific application for a small particular band. So that's why that band how defined by the IEEE, these are only the band. Okay, so that is about L band, S band, C band, X band, KU band, K band, KA band. Now each and every band they have a specific applications there. So now if you see here, it is a L band that is about from 1 gigahertz to 2 gigahertz, and here a mobile satellite services, we can say that whatever you people are using that mobile phone nowadays, okay, that is about mobile satellite services, okay, or a satellite phones or a mobile phone. Likewise, we have a television there, okay, okay, so we have a link there, we have a, okay, so these are about the various applications we can look for this particular L band, S band there, that is related to the mobile and all. Now this is about a S band 2 to 4 gigahertz, okay, mobile satellite services. We are using this particular in a research work here. That is about a satellite band we have. Okay, C band, that is about the fixed satellite services band there. Now then here is the issue that is about 4 gigahertz to 8 gigahertz, because these are the satellite service band. It is useful for the communication there. So satellite phones and all, okay, they are using this particular satellite services for this application there, this particular band. And then this is a common band, X band is a common band, that is about the 8 to 12 gigahertz. Generally it is 12.5, okay, but people are saying 8 to 12, then it is about the 12 to 18, not zero point 0.5, okay, so 8 to 12 gigahertz. And this particular band of a frequency, X band, will perform our practical. Okay, so we have a lab, and in a lab some equipments we have, and that equipment they are working in this particular 8 to 12 gigahertz of a frequency. So we say that these are the 8 to 12 gigahertz frequency, FSS, military communication, fixed service terrestrial, earth exploration, and meteorological satellite there. Then a KU band, general 12 to 18 gigahertz, that is about the FSS, okay, broadcast satellite services there, fixed service terrestrial microwave there. Terrestrial means what? A communication, okay, from this surface to whatever we have to the satellites and all, okay, or we can say that we can communicate to the long distance terrestrial communication, okay. Then a K band 8 to 26 gigahertz, 26 to 40 gigahertz. Now these are about the IEEE band that is given. But if you consider that this particular band of a frequency 0.3 to 3 gigahertz there, yes, we are saying, okay, 300 gigahertz, and that wave is very very small. So that's why if you see that here it is mentioned that extremely short waves or a sub millimeter waves. Okay, so means above this 40 gigahertz, this is about a very very small wave, and that is about, we can say that it is about up to 300 gigahertz, very very small, and above that 300 gigahertz, it is about a sub millimeter waves. Okay, 40 to 300 gigahertz, that is a millimeter wave, and above that we can say that it is about a sub millimeter waves. Now a US military frequency band, that is about a radar band, they have mentioned there, okay, that is about the frequency region. Then these are about the bands, okay, so these are about the band definition by the US military frequency microwave frequency band, okay, that are used in their radars there. Okay, so we are interested in this particular frequency band, not interested in this US military microwave bands here. Just I have just added that particular side because of that some applications are there that is in a radar band, and people are, which people are using those particular band for what applications, okay, so that's why we have added this particular band there. Another one, that is about the new radar band. Earlier about, okay, so they have defined the different bands there. Okay, this is about the new radar band. These are the frequencies, designation of band by the US military. Okay, so here we start with the microwave there, and we before we start with the microwave, we should know that why we are learning this particular microwave communication there, and what are the use of this particular microwave frequency communication. So that's why we need to learn here their particular specific bands of frequency and their specific applications there. Now, if you see that a micro region, that is, we say that is about the zero point 0.3 gigahertz to 3000 gigahertz, that is entire, that is about the band from this radio spectrum there. But if you see that where when it has developed this particular micro frequencies bands and all, okay, so we just learn that what developments have taken place in this particular micro frequency band. Earlier, people have used only a small band, but in the World War II, that micro frequency or that radars have developed, okay, in a World War II, and they have used for detecting and locating enemy planes and ships through this particular electromagnetic energy there. So that's why we see that here these are about the specific narrow bands available there. Okay, so that is about they have used in the application there. And again, if you consider that wavelength is small, so then what happened? Because of the small wavelength, we sorry, someone have written something. Okay, hello, is it okay now? Audio is okay?
Yes, sir.
Okay. Now these are about a specific band. Even if we are saying, but they have a different applications at a different band there, band of frequency. Since it is a high frequency there, so that's why a generally what we are saying, why we are using a modulation, because of using a modulation antenna size is to be reduces there. So similar thing is here, because of a high frequency antenna size will be a small. Okay, and if we are going ahead with a large diameter of an antenna, so we will get that narrow beam. So that's why a dish TV, if you see that in a dish TV, that it is a narrow band one. So sorry, not narrow beam. So dish TV means we are using a large dish for a transmission or a reception purpose. You people are having a dish at your home. Okay, that is a receiver dish. Okay, that is parabolic dish or a circular dish there. Now, if you consider that a large diameter of a dish, so we'll get that narrow beam, and because of that narrow beam, we can radiate the signal for the long distance, and it has having the high gain because of that narrow beam there. So generally, that antenna size we are saying it is depending upon the wavelength. So that's why you people have learned earlier that is about the modulation. So in which you people have says that because of that modulation we can reduce the length of that antenna and all. So generally a size of the antenna we say that it is depending upon that wavelength. So that's why a, the size of the antenna carried by the any aeroplane or any mobile devices, it is very small. Because of that, it is of a wavelength is a small there. Okay, that lambda, okay, it is in a centimeter or a millimeter. So that's why it is about a small wavelength. So you look for this particular characteristics of a microwave. So short wavelength or a small wavelength. Because of that a short wavelength or a small wavelength, we can easily uh, develop or design an antenna, and that is for the particular wavelength there. Okay, it has a small wavelength. Small wavelength means frequency is large, lambda is equal to what? C by F, because F is in terms of what? 10 raised power 9, giga means 10 raised power 9. So that's why we are getting a small wavelength. And because of the small wavelength, if you consider that a band, for any band here, and for a given particular application, so we are getting naturally the bandwidth will be more. So more the bandwidth, so that's why the capacity, information carrying capacity will be increases, because of the small wavelength, bandwidth will be a large there. Now, for example, I am saying that is for supposed to be a speech frequency, okay, or we are saying any applications, and it is in terms of MB, okay, uh, that is about the megahertz, sorry, and in terms of a megahertz there, suppose applications 10 megahertz to 20 megahertz, means we are getting a band of what? 18 megahertz, that is the bandwidth. But if you consider that 1 gigahertz to 2 gigahertz, so specifically bandwidth is in terms of a gigahertz. So that's why a bandwidth will be more. So more bandwidth. Then because of that wavelength is small, so that antenna size is small. And because of that small antenna size, okay, so we can get that large antenna again. Okay, so we can have a narrow beam antenna we can design. Okay, so that is about we need to design antenna in such a way that we will get that narrow beam there. So we have a small antenna side. So signal, generally we say that a signal is propagating in a free space. So micro signal can be propagating in a free space. There is if okay, any obstacle will come. Okay, it will be penetrate through some obstacle and it will be reflected back. So generally we say that it is propagating in a free space. So that's why you people are getting the signal on the mobile phone. So it is propagate in a free space freely with a small attenuation. So that's why we are getting the signal. So we can consider that when we use any antenna that is for or a micro that is for the travel by line of sight propagation through the ionosphere with a negligible absorption and a reflection. That is for a ground travel line of sight for the ground communication it is possible, but there are limitations for what a 50 kilometer. If you transmit the signal from one antenna to the another antenna, both are ground antenna. So the distance between the two antennas should be a minimum, maximum 50 kilometer. And if we increase that distance, so then your line of sight communication will not take place. Why it is not takes place? Because of that earth curvature. Okay, so we will not get that line of sight of propagation from one antenna to another antenna beyond that 50 kilometer. So that's why there is a limitation. Because of that earth curvature, we can specify our transmission line of sight from one antenna to the another antenna beyond, okay, below the 50 kilometer of a range. But if you say that here, a travel by line of sight propagation through the ionosphere means that is in space. When we are looking for the satellite application, if we are looking for this particular satellite application, signal is propagating through the space. Okay, and in a space there is a layer, different layer. So here we are saying ionospheric layer is there. There is a, because of that ionospheric layer, there will be absorption and a reflection there. We'll see in a detail about those ionospheric layer, because ionosphere layer changes in a day and night. So according to that, your propagation or your signal absorption or reflection will be different there. So again, we can say that your signal is propagating in any dielectric medium. Suppose, okay, then it can penetrate through the any dielectric medium. Generally, we say that it is the air. If it is air filled medium, and your signal easily propagating through the air. If it is a wood, okay, it will easily propagating or penetrating to that particular material there. So but if there is a metal, okay, if any metallic component comes, so then what happen, your signal get reflected. So your signal easily penetrate through the dielectric material, but signal will be reflected from what, a metallic surface. If there is a reflection, okay, reflection occur, that is from what, if there is any metallic surfaces there. Because wave is propagating, so we are saying that there is a metallic surfaces, it will be reflected. If supposed to be that surface is about, instead of metallic, if it is a conducting one, okay, good conductor suppose, the signal will not penetrate through the good conductor, but it will be penetrate through the dielectric material. So reflection from the metallic surfaces, your signal will not penetrate through the conductor there. Okay, so this is about the characteristics of a micro there. And then another characteristic is what? Micro heating. Micro heating means what? At a particular micro frequency, that devices get heated, that dielectric material property will change of the each and every material because of penetrating that micro signal through that particular medium. So it get heated. So we are using this micro heating technique in a lot of applications there. Now you people have micro oven at your home, or this micro heating technique is used in a medical applications there. So when somewhere healing or something occur there, okay, so in that case we can use a micro heating there. Then we can use this micro communication or micro signal at a molecular or atomic or a nuclear resonance, because at a particular frequency band resonance occurs. So that's why we say that it will be used in these particular cases. Okay, that is for the, these are about the characters of a micro. Again, one more characters of a micro is what? Generally, we say that microwave is a small and wave is cannot propagating through the coaxial cable. If any signal propagating through the coaxial cable or wire, then current will be there. But here, signal is not propagating through the wire; it is propagating through the waveguide, or it is in a space there. So then, that whatever the current relation will not come in a picture, current or voltage. If it is propagating through the transmission line, then there will be current and voltage will come. So that's why KCL or KVL, that is that laws, okay, KCL or KVL laws, or whatever the concept of a voltage and current, that will not applicable to this particular micro frequencies, because at a high frequencies, the signal will not propagating through the transmission line, and because that signal will act as a radiator, that transmission line or wire will act as a radiator. So that's why no voltage or a current concept applicable to this micro frequencies. So we could not define this micro frequencies in terms of electrical or a, or you can say that voltage or a current relation there. We can define only in terms of a wave. So to analyze the circuit at a higher frequency, we need to consider that electric and a magnetic field. Okay. So we can analyze our circuit theory. Now these are about the various applications of a microwave. So we can use the microwave communication there for various ways we can have microwave communication systems. Okay, microwave related applications. Then we have a radar systems and a countermeasures there. Then radiometry and radioastronomical research. Radiometry means what? We can find out what will be the weather and all. Industrial applications, if you consider that, there are the micro heating use for cooking, or we can have, uh, if there is a painting shop and all, then paint will be a weight, suppose. In that case, to dry this particular paint for or whatever the dyeing we are having, to dry those, so that microwave signals are used. So industrial applications can be used. Then we have biomedical applications there. We can use this microwave signals. Biomedical means what? A medical applications. And then we have a potential applications in the field of what? Energy transfer. Energy transfer means what? We can is supposed to be a remote area, and in this particular remote area, we could not provide that wire, or could not provide that okay supply there. So in that case, we can use this energy transfer, or we can send the high frequency signal in that particular end, and that convert that high frequency signal into the power one. Okay, so that's why you can say that a field of the energy transfer there. So generally, these are about the applications of those particular microwave frequency signals. And if you go in a detail of those particular applications, so we need to know about what are the specific band of frequencies to be used for the different applications. Generally, we say that, I think maybe there will be a side. Okay, so we have this 300 megahertz to what we can say 3 gigahertz there, that is used in a TV band, television, satellite, okay, surveillance applications there. Okay, so you can see that meeting will end. Okay, okay, so it will end after 5 minutes. This meeting will end after 5 minutes. Again, rejoin. Okay, again, you rejoin this particular applications. Okay, if that meeting ends, suppose after 5 minutes, all of you listening me?
Yes, sir.
Okay. If supposed to be by any means, supposed to be that meeting ends, you rejoin after, okay, after 1 minute. Okay, because it is saying that after 5 minutes, because it is a 50 minutes meeting, and our lecture is about 1 hour. Okay, so it is showing that particular message. It will be okay. Okay, let it be. Now we can come to the particular topic. Now these are about the applications we have. Sorry. Uh, Now these are the applications we can consider here. There is about a 300 megahertz to 3 gigahertz there. Then 3 gigahertz to 30 gigahertz. That is about what we can say that super high frequency. If you see the band of a frequency band here, 0.3 gigahertz to 3 gigahertz or 300 megahertz to 3 gigahertz. There is about the ultra high frequency band that is used for. These are the point to point applications. Okay, point to point communication, satellite communication. Okay, there are about the various applications we say. Okay, satellite communication, if you see that it starts from the 1 gigahertz to from 1 gigahertz to 3 gigahertz there. Radar, okay, most of the people know that a radar is used for identifying that particular component or particular object at that particular place, find out the there is speed or it is presence at that particular point there. Okay, navigational aids, we can consider that, okay, for identifying that position. Food industry for the microwaves, point to point communication there. Next, about a 3 to 30 gigahertz band that are the use in the application there. Okay, then a 30 to 300 gigahertz, it is called as a extremely high frequency. Okay, this is about is ultra high frequency, super high frequency, and this one is about the extremely high frequency. Now, you you people know that a radar, that is nothing but what, a radio detection and a ranging. Okay, radio detection and ranging means what? Detecting particular object and what will be its range or what will be its place or what will be its movement there. So we can find out a radar and their applications there. So we can go ahead with the applications for all this particular band there, where we see that uh, applications there. So now consider that it is to be used in a micro communication, all these communication related applications we can consider these micro signals there. Okay, so we have a various applications in a micro there. Similarly, we say that a radar for detecting if ships or whatever, we can say that detecting a object, any planes or a ships there. So that's how you can use a radar there. Again, a radars are used to detect again or whatever the conditions are a particular object, whether that or object is ongoing object or it is present at the air, present in the air or it is present on the that ground there. So we can easily detect that particular object using this radar there. And again, it is used also used in air traffic control. Most of the if you see that airport and all, so that radars are used there in a traffic. Okay, for air trafficking. So that's how you can say that it is used in a air traffic control. Again, it is used for the missile tracking. That is nothing but that missile is nothing but an object, and we can track those objects to find out the position of that missile there. Again, we can create a signal to any signal from the radar to avoid transmitting the signal from enemy. Okay, means we can say that a noise signal we can create so that another people will not able to use their own radar.